To find the missing angle of a right triangle, we use our trig functions sine, cosine, and tangent. And remember that sine from SOHCAHTOA, S-O-H, means sine equals opposite over hypotenuse. Cosine from the SOHCAHTOA, C-A-H, is cosine is adjacent over hypotenuse. And TOA from SOHCAHTOA means tangents opposite over adjacent. And so we use these trig ratios to find, and our calculator to find the length of or measure of an angle. Now say we want to find angle F. For this right triangle, we have the value of all three sides. Opposite of angle F would be 5, adjacent would be 12, and the hypotenuse 13. Since we have all three sides, we can do sine of F and use 5 over 13. We could do cosine of F, 12 over 13, or we could do tangent of F, 5 over 12. It doesn't matter because we have all three options available to us. So I'll just pick to use sine. The sine of angle F equals opposite over hypotenuse, 5 over 13. And what I set up here was a trig equation that goes function angle equals ratio. Function angle equals ratio. The function is sine, the angle is F, it's an unknown, equal to the ratio that we get from sine is 5 over 13. And that's an important concept to remember, that function angle equals ratio is how you set up a trig equation, because that's used a lot in trigonometry. But now that I have the function and the ratio, I can find the angle by using my calculator. And what's important is that when we're finding angles, we use the second key in our calculator. So I type in second sine 5 divided by 13. Close the parentheses. And that gives me a value of 22, I'll round it to the nearest tenth, 0.6. So angle F is 22.6 degrees. And I didn't have to use sine. I could have used cosine. I could have done cosine would be 12 over 13. I could have typed second cos 12 over 13 or second tangent 5 over 12, and it would give me the same values. For the next example here, the difference is we want to find angle A. But we're not given all three sides of the right triangle. Now we could do Pythagorean theorem and find that missing side, but we don't need it, because if we have two of them, what do we have? From angle A's perspective, one is opposite, rad 3 is adjacent, and that's enough. Now we can't do sine because sine needs a hypotenuse. We can't do cosine because cosine needs a hypotenuse, but we can do tangent. And that's what's important here, is as long as you have two sides, you have one of the trig ratios you can use. And so you're limited to only one trig ratio, but it doesn't matter because that'll work just fine. So function is tangent, and that's determined by the sides that we have. Opposite and adjacent has to be tangent. Function angle is tangent A equals the ratio. Tangent's opposite over adjacent, so that's 1 over rad 3. And I could rationalize 1 over rad 3, but I'm going to let my calculator do the work for me. So we're dealing with tangent. Second tangent, 1 divided by rad 3, and I get that from second x squared. That's how I get a radical 3. Just going to move over and make sure I close my parentheses properly. Enter, and we get angle A is 30 degrees. And, so an important thing to remember is the use of the second key. The second key is for finding angles. If we were finding the length of a side with sine, cosine, and tangent, we would not use the second key. It's only for finding angles.